Welcome back again. In this part, we will learn about functions. And then let's create actually a function. Oh yeah. Do you see my screen, guys? I'm sharing screen. Okay, I hope so. Great. And let's say functions. Yeah. Now, so what's function actually? It's a block of code that can perform a certain task. Yes. Yeah, we've been writing code without function and everything is everywhere. And functions can be reused, yeah, or called many times, reused. And functions are easy. If we write our function, if we write our code in a form of function, functions make our code clean, readable, maintainable, and testable. Great. That's good way. And we have been using different custom built-in function such as the print, the len, the absolute value, the string, the input, the float, and yeah, and maybe the dir, the round, and the list, the tuple, and the dict functions, etc. to perform certain tasks. And today we will write our custom function. Great. So, but we can start actually by checking what a function looks like. Let's see print. The print function, which is a built-in function. As you can see, it has a name. The name of the function is name. Print. The name of the function is print. And whenever we call it, we use this two parentheses, the parentheses, that means invoking the function. If I invoke this and nothing, as you can see, and then if I say print, maybe with something, and then you will see that. So this is actually an input, or we may call it an argument. So that's actually one of the input, and maybe now hello, and maybe another input, I could say to 24. So as you can see now, we have 3 arguments in this function. So function do have a name and then an input or argument. In this case, 3 arguments. Now let's create our own function or declare our function. To declare a function, we need actually the def key, the key reserved word or key. And then followed by the name of function, I call it do something, do something. This is the name of the function. And then something like this. After that, you need a colon. After this, inside the block code, I can write anything I want. I can say, I am teaching, actually I can say, I am teaching Python right now. Okay, good. Now, if I run this, nothing. Okay, now we create a function, we declare the function here. The name of the function is do something, and inside that function, we are printing this. But nothing happened. To see the value, I have to call the function do something by its name. For instance, I have students now in the classroom. How many students? I can see 16 students. Everybody just sit down and just listening to me or watching what I do. But if I just call you by name, you might be alerted, right? Yeah, because I called you. The same goes in here. The function, unless you call the function, nothing happens, okay? But now I called it here, I should see something will be printed out. Yeah, I'm teaching Python right now. Yeah, great. Maybe let's do greetings. Def greeting. And then this greeting, I can say print hello world. We are greeting the world from the beautiful Helsinki. Great. Now again, if I do this, nothing happened, but again, I should call greetings. Yeah, and then let's see that. But maybe I might be interested, Hello world, we're greeting the world from the beautiful Helsinki. But my function is now, right now, can be used just by only, like, Helsinki. Maybe for someone from Tallinn or maybe from Stockholm or Copenhagen want to reuse this function, then actually the message here. And then I can inject that message with a string interpolation, then maybe the city name, maybe I think here, message, as you can see. And then now I can call it from Helsinki. And let's see. Hello world, we're greeting the world from the beautiful Helsinki. And maybe how about also greet if we move because somewhere else, and we can still greet the world from Stockholm or maybe from Oslo. Have you seen now the usability? And maybe from Copenhagen too. Yes, let's see. Yeah. Now, yeah, Helsinki, Stockholm, Oslo, and Copenhagen. We call this parameter. As you can see, it seems that we are interested in more cities. So how about if we customize our parameter to city? Yeah, something like that. Is it clear so far? Yeah, now it seems like, now how about if we create a function that add just two numbers? Def add two nums. Have you seen this function? It seems it has a specific purpose, and I would like to tell you, try to make your function as specific as possible. Don't do too much stuff in your function. Yeah, don't write generic because it's easy to test and it's easy to maintain, read also. Add two nums. So I'm expecting X and Y, or num1 and num2, or maybe whatever, and B. Yeah, that's easy, right? And then I can say print A plus B. Great. Now this actually print, no. I actually just do add two nums, 1 and 2, add two nums, maybe 99 and minus 99. I'm expecting 0 for that, yeah? Add two nums and maybe 1 plus, no, 1 and 99, I'm expecting 100. So I'm expecting 3, 0, and 100 here. Let's see. Yeah, it's working. But so far as you can see, I'm printing inside actually the function, and it's better to return value. Return means actually, like in real life application or projects, we return the value there like this. It means we are storing, we process, for instance, you may call this, even before that, you can say total, and then put it here, and then you return the total. Or directly, you just return this value. and still it should work. But, you know, this needs actually, we have to print this value. So I have to say print, and then maybe again in this side, I have to add this additional. And now, as you can see, 3, 0, and 100. Yeah, because return. So if we are not returning, we are not actually storing the value, the calculated or the processed data. Instead, we are just flashing it, you know? So we should return. Now, maybe if you remember, we've been just working on different a different project. Maybe I think I come that later, and we can actually change the different problems we solve now with function. How about now if we add someone div print full name, full name. As you can see, maybe it takes first name and last name. Yeah, and then you may say that's good actually. Yeah, it's this is suggested to me. You can do something like first name something, but instead I want to return that. Return the first name and the last name together. As you can see, this is string interpolation or concatenation in a more latest way. So that's, I'm happy. And then I can say print first name, no, print full name, and then I can pass my name and then my last name, and then maybe another. I can copy this all over again. Donald Trump. Yes. Yes. And yeah, then I think that would be good. Yeah, that's good. No, maybe, do you have any questions? Maybe how about if we do a function that sum numbers, def sum all nums, and then it takes this. That means if I pass 100, it should sum all the numbers from 0 to 100. Yeah, so I should say n. So how do we then get? It's easy, right? Then you may say, I think this it's suggesting me just like crazy, so I have to disable one of my tab 9. So tab 9 is I use AI to suggest the possible code, and we're not learning in that way, so I have to disable that tab 9. Yes, for the time being, because uninstall, thank you, and reload. Yes, good. And then we will work using, we use our brain then after that. Okay, good. It takes. So to generate the numbers, we should say range 0 to n. So since n is not inclusive, plus 1. And what we should, then after that, we iterate through. Or maybe total is equal to 0. Maybe the easiest way, you can start it without a function, because you will have a chance to see each step. Range, let's see up to 100, right? If we are going up to 100, so maybe 101. And let's see what we get. Yeah, yeah, I got this one. But how do I print the, or I print in. So I can loop. I forgot to pass the I. And then actually I print from 0 to 100. That's great. But how about if we say total here and then 0? And Then we can sum this all up. Total is equal to total plus the I. And then, yes, but I think now we don't have to print this. Instead, if we go here and print the total, I think I should get something like maybe 50-50, something like, yeah, 5,050. Yes, that's the sum. Okay, but the problem in here, this is just only for 100. Sometimes we may change. So instead, let's change this to a function, def sum of all nums. And then, as I told you, this one should be dynamic. So instead of 101, we should say it n plus 1. Okay. And then after calculation, we have to return this. Return the total. I think, yeah. Now let us try. Print sum of all nums of 2. I'm expecting 3, right? The sum of all numbers from, because 0, 1, 2 should be 3. Yeah, how about print sum of all numbers of up to 10? What is it, by the way, up to 10? Is it 55 or something? Yeah, 55, yes. Print sum of all numbers of up to 100, and then it's something like that. Yeah. But this is one approach, and we can make even this function a bit shorter by using a built-in function. I will show you. For instance, instead of going all this loop, how about if I just take this part only? And I don't need this. And then actually sum. How about if I do this? This create already a list, and the sum will take care of the adding. And then let's try with this one. Oh yeah, yep, this is much prettier and shorter. Great. Maybe how about if we want to reverse a list? Yeah, maybe if I say def reverse list function, it should take a list, something like that. Then what I should do, is there a reverse method already? Yes, there is a reverse method, or shall we do it in a more like manual way? Okay, so I think before we create the function, it's better to just try to solve it without the function, because it's easy to see. If we have a list, 1, 2, 3, 4, of course, we can use just list dot reverse, and then print a list, and this will reverse the list definitely. But maybe if I am like, no, I don't want you to use the method, I want you to reverse it manually. How do you do that? Then what you should do, for I in range, the length of the list, what does this give us? Let's see. Print I. Okay. As you can see, 0, 1, 2, 3. I managed to get the index. And then, of course, I can also get the value using that. As you can see, yeah, just all that. But I want to get this them in a reverse order. So how can we reverse them? So if we start from this one, this is actually the length, but -1. Okay, -1. And then we should stop at -1. And we should decrement also this, if you remember. Now, if I just do this, yeah, actually it's reverse it. So now reverse it, list as in empty set, as an empty list. Then I will append this value now and then during the iteration. So reverse it, list dot append this. Okay, then print reverse it list. 4, 3, 2, 1. Yeah, then I think we just made it so we can reverse list the name of the function, and it takes a list as in a parameter, and then I can just put this code inside and change to a function, and then this instead will be returned instead of printed. Yes, and this should be removed because we don't need that, but we can actually pass it as an example. Okay, so we have a list example here, and then, but I have to remove that space. Then print reversed list, and then list as in example, this one as in argument. Yes, as you can see. By the way, this works only for list. How about if we want this to also work for maybe we can make it to work for set, but there reversing, there's no reversing in set anyway, but this is good enough. I think we have list of people at some point, for instance, my student's name somewhere, and then I can just take that and see. Now, for instance, this one, and print reverse list, and then students, and this should be now, Christina should come to the first. Christina comes to the first and Alexandra to the end. It's reversing. Okay, great. Now I just want to show you, how about if I give you a simple task and then you solve that. The task is actually, I will give you 5 minutes after that, okay? It's going to be like this. Calculate the weight of a body in different gravity. I mean, gravity is different at the moon, at the Mars, and on Earth. But let's make the gravity of Earth default for our function. So the mass of the person could be vary, but you can test it with mass of someone, maybe mine, 75 kilogram, and also test it with 9.81 gravity of Earth. So the name of the function is going to be calculate weight. Okay. Yeah. So I will give you 5 minutes for this to solve, and then after that we will work together. Everybody, well done. Everybody did well, and I'm satisfied with your answer, guys. So, but I think at some point it would be good. Now let's take gravity of planets, maybe. Yeah, gravity of planets. Let's see. As you can see, the Earth is 9.81 and Jupiter 24.7 and 3.7 Mercury. Okay. Earth 9.81, Jupiter 24 point something, and Mercury 3.7 something. I think that's what I remember. 3.7, but 24.79. 79. Okay, 79. What was, I think I like Mars 3.71, whatever. What was the gravity of the moon? I think it was 1.62. Yes. And moon 1.62. Great. Now let's actually then I weigh about 75 kilograms, so it doesn't matter, but anyway. So let's create the function, and the name of the function is calculate weight of a body in certain planet. So mass and gravity are actually the parameters. And then what we should do, weight. Weight is equal to mass times gravity. And then we return the value of weight. Great, now let's start printing. And then we say print what would be the weight, calculate weight of me, 75 kilogram, and at planet Earth, 9.81. Okay, let's see. As you can see, 735.75 Newton. That's great. But how about if we do this at planet Jupiter? Yeah. And then maybe, what is that? 24.79. Okay. Now let's see. It would be very big. Yes. What? Yeah,
Change your weight.
I should change this one. 24.79. Good. And wow, it's almost 3 times, almost 3 times. Yeah, okay. And print, let's see our weight in the moon. Maybe I think in the moon is like almost weightless. Because it's 1.62. And let's see, it's very small. Yes, in this case, I think it's good to round, right? Yes, round this value. And then I can just maybe to the two significant digit. And if we do that, 121.5. It's good, right? Yeah, this is one function, but as you can see, there's a repetition, right? If I ask you like to calculate your weight, everybody will use 9.8 because everybody here is on planet Earth, right? So by default, most of us will not have a plan to go to the other planet. Yeah, so I think gravity would be default. So what we can do, maybe we can just pass a value, something like this, 9.81. So we don't have to pass here like this. Yeah. But, so as you can see, like that, and it should work. Now, maybe one of you might have some weight, maybe someone bigger than this, like maybe some of you might be 85. And let's see. And you are still on the planet Earth. If you are on the planet Earth, you will use the default value of gravity, 9.81. So have you seen? This is how we pass actually default value. Great. What else can we learn in this part? I think what I would like to teach you now, maybe I think before I move on to other part, I want to go through the material because there might be something we may miss. So as you can see, function And defining a function, we know declaring and calling. Declaring means creating a function like this, and calling, you call by name. For instance, if I call you by name, you may say yes. Yeah, some of my students, and maybe Alexa, or maybe Elena or Erina. So yeah, you are alarmed already. So that's actually calling a function. Function without parameters. As you can see, there's no parameter in here, and just inside we have some process, and then we just print something. Usually a function without a parameter is not robust, something like this. But function returning a value, as you can see, I processed this one and then returning a value here. Still, this doesn't have a parameter. So we may have a function without a parameter, with or without a parameter. And again here with a parameter. So for instance, greeting of a name and the name plus, then we add this. Welcome to Python for everyone. Okay, great. And then add 10. So this function actually add 10 to any number. So you pass any number. If I pass 100, then it will be 110. If I pass 90, and it will be 100. Square, make a square. For instance, I think I will show you this function, def make square function. And then I may have n. Then I can just return this and something like this. So this function actually just make square function. If I give it 10, it should give me 100. If I give it make square, and if I give 7, it should give me 49. Yeah, that's make square function. So area of a circle. Yeah, do you remember we calculate the area of a circle, but now in a more function form. Area of a circle, and then we have to take radius as an argument, as a parameter. Pi, this is constant all the time. And then, so we can keep it here. And then, yes. Okay, if there's something new that I can pass argument with key and value. Yes, I was about to forget this one, so I will include this one. As you can see, there's parameter 1, parameter 2, and the order of argument does not matter here, but the order of argument does not matter here only if we have value for all the keys. Yeah, let me show you. What does that mean actually? I can show you. So now, for instance, def. But how about if I just take the same example instead of thinking about a new example? Print. Yes. This one I can explain to you. Here, print full name. It takes first name and last name. And this space is actually to be in the middle. First name plus space plus last name give us the full name. And we are returning this. Now, as you can see, we are using this value like this. First name passing actually the what's passing the input differently with a name. Named input, we call it this named input. Now, if we exchange, if we change the position, it doesn't matter, because as you can see, it is labeled name refer to this one and first name refer to this one. Yeah, of course, I have to print this value. Print this value, and I should get the same thing. And then if I have also, what is that? The different version, maybe this one in the other side, and it should also just work and give the same thing. Yeah. So named input. Maybe another function with default parameter. It's the one we have seen already. arbitrary number of arguments. That's very good. And this is something we should cover also here. What is that arbitrary number of arguments? Arbitrary number of arguments. Do you know this, the print function? How many arguments does the print function takes? Yeah, please tell me how many does it take? The print function can take actually unlimited number of arguments, yeah, or arbitrary number of arguments. So you just take whatever amount you have. So how can we create actually? Now, if you create actually some all nums, some all nums, or some all nums, and if you have 1, 2, 3, 4, 5, and maybe you don't know, just it will continue. How do you sum all this together? Yeah, we have this symbol, the star sign, and this actually allow us to create a tuple of the arguments. Okay, I will show you. What does that mean? Now, for instance, this, maybe I can create the function first, def, and then I can say, hey, star argue args, or you can call it anything, params. And then let me just print and show you the params actually. Yeah. Now the params actually give me all this value as in a tuple. Let's see. Yeah, great. If you get this in a tuple, then it's easy to sum all that data together. Then I can just use the sum and then params. Yeah, as easy as this. Look at, and then I just print this. It should give me the sum, 21. Can I increase this? Yeah, 21. If I add 21, then if I add actually 79, I think most probably 100, right? Yeah. So how about if I add 900, and it's going to be 1000. And if I add minus maybe 500, and it would be, so as you can see, you can add unlimited number of inputs or arguments. So if you have a plan to create a function that takes unlimited number of parameters, I mean unlimited number of arguments, so your parameter should be written like this: star followed by some whatever text, but most of the time we say args, that means arguments, like an abbreviation of argument, or params. I use params, it's just my style, but I think the standard is args. So now let's be more conventional and follow the standard and change this to args, and it should work again. Great. Yeah, let's move on. And that was that. And I think there is something left. That is the double codes, the quarks. We call this the args and quarks. This one just create this one create just a tuple. How about if it was actually double? And later see double dove. Create some structure. I will show you, or struct for the time being, and I quarks. And let's see what do I get from this quarks. This quarks, whenever we use these two asterisk or star, actually it creates a dictionary. Okay, then maybe if I say print create structs, and then if I say 1, Okay. 1, 2, 3, 4, and let's see what it generates. As you can see, but for we're given, what? Yeah, anyway, as you can see, it just generate this. Yeah, have you seen? We got a dictionary, and then maybe, how about if I pass it? I think it would be nice if I use an example that I have somewhere, but no here. How is that possible? Or maybe, whoops, I Yeah, as you can see, this args, it gives you a list, and this gives you actually a dictionary. So something like that. Yeah. Then this is more for this part, and this part, the key value is going to be this part. So what I should have done, actually, I should give something like this. For instance, name first, name, and I should say my name. Okay, we can start with just one value. Have you seen it just created a dictionary? And then if I say last name, and then it will, and you know my age, right? And 150, and skills, and maybe I can put it as in, and Python, and Node. Yes, good enough. As you can see, this the Quark created a dictionary for me. So that core, then I call it create function with Quark. Func with, yeah, I should change also this one here. Just I'm giving you some demo. So what's the problem in here? Yeah, you know, if you just create a function and if you don't have value, you can't keep it like that. We should pass something like pass or something. So we can see now for like key in coargs. Now let's print the key and let's see. Key is not a reserved word. You can call it item or whatever. And let's see. Yeah, first name, last name, age, skills, yeah, something like that. Okay. Then from that, and then coargs, and then you can pass the key, and then we can actually access each value. Yeah, the first name is, that's just my first name, the last name, and the age is this, and the skill is this, and we're not returning anything. Yeah, so, but if we have a purpose to return something, we can process and return. I think that is all what you need when it comes to function, and we have covered everything. And now what is next is lambda function. What's this lambda function? Okay, in other programming language, they call them anonymous function, or a function without name. A function without name. Why? So far now you know a function. It takes, like, it has a name, but this doesn't have. But we use the word lambda. And then This is actually the parameter. For instance, to create make square, this is how we make it, as you can see. Yeah. Yeah, but now maybe I think I have to store this again with something, you know? Maybe X or maybe Y, X, Y, Z, for instance. Oh, guys, don't store something like X, Y, Z, but I will just show you. Print X, Y, Z. What did we store actually in X, Y, Z? A kind of a lambda function. As you can see, we stored actually a function. Does it take, yeah, it has the parameter, yeah, so that means it takes one argument. So if I pass 10, I should get 100. Yeah, so this means actually make square in a different way. Yeah, so let's give it a better name, make a square. Yeah. Okay, good. So then if that's the case, now, for instance, how can we solve a quadratic equation? If you remember, quadratic equation is something like this: x squared plus 6x plus 9, right? 9. Okay, now if I have actually, yeah, so now of course, the value for this one is just, it will be just x, but this is not a very good example. Now, maybe, yeah, it can be solved like that. So I could have, for instance, the value, maybe just the solution set for this is -3. Yeah, so let's say just lambda x, x square. I think that's not how we write, no. Why is that? Yes, like this, x squared plus 6 times x plus 9, right? Yes. So now I can just, what's the value in here? Oh, print value of -3, 5. So I'm expecting 0. Let's see. Oh, yeah, good. Because as you can see, I have already calculated in my mind x squared plus 6x plus 9. The solution set is -3. But if we want to write the equation, it should be something like that. How about if we have an equation something like this? Lambda and x, y, z, and something like this. So 2 times, no, maybe 2 times x squared plus 2 times x times y times z plus y squared plus z squared. And I would like you to solve this, and then I will give you the value of x is 2, and the value of x is 2, the value of y is 4, and the value of z is -3. -3. I would like you to solve this in 5 minutes. Now, I'll give you 5 minutes. Okay, could you share your solution with me? I think it should be just a number, -15. Someone got -15. Great, yeah. How about others? Did you get the same value? Just write anything you got. Okay, -15 Irina, and 2 people got -15. Anyone who got, oh, then I think if 3 people got the same thing, I would say the value might be -15. Let's see it together, guys. Yeah, so I think we can just call it solution. This one, maybe then, I mean, maybe we can store it as in a solution or something, whatever. Value is just it's a bit weird because it doesn't have name, so that's Then the use case, we will see how we will use actually lambda. So solve solution for that. So actually, yeah, just you pass actually X, Y, Z, 2, nothing you can do with that. But I think the way I asked you was a bit not a very good question. I figured out. So I have to ask you in a different way. So you just put it like this and just you get the solution. And this is really not, yeah, minus 15. So I should have actually asked you to solve, to put it differently. So now watch again. So I have to give you another equation again. Maybe it should be an equation like this, a linear equation. So ax plus by is equal to c. So this is like a linear equation, right? And then maybe in this case, I call for x plus 6y, and c is going to be 10. Then the value of x is equal to 2. The value of y is equal to 4. Now find yeah, I express this in so find this. Okay. Of course, using lambda function. You can just solve it also without doing anything, but I want you to write it in a more lambda way. So I should see your lambda implementation and the value now. And then I will give you maybe 1 or 2 minutes for this one.